Good morning, good morning, good morning, organic chemistry. I'm really excited. We're going to have just a fun, quick video for this one. We're branching out and we're getting past just carbon and hydrogen and single bonds. So as we're moving into our other units of acids and bases, and we're going to do some radical halogenation and start our actual reactions by our next unit, I thought we'd take a chance to get past just alkanes and give you a nice cheat sheet worthy list of where we're headed. So instead of just alkanes, let's move into other atoms and other functional groups. So this video really, on purpose, we're going to look at this one before IR spectroscopy and before we get a little bit too busy in some of our acids and bases. So let's line up functional groups that are really common for organic chemistry. And this list is going to take you all the way through OChem 2. So we have some basic functional groups that really are pretty stable and commonly found in nature. There's a lot of them, but 90% of our OChem 1 and our OChem 2 is going to come from this list. We may have the occasional reagent that veers off this list, but as we're getting into problems like our road maps, how fun are those? We're going to start to include other functional groups in our road maps, and I don't want you spinning your wheels, drawing 6 bonds to oxygen that just aren't possible. So I will always stick to this list in our road maps. I'm not going to have anything in there that is not a functional group on this list. I'm also going to stick to this list for our next section, which is IR spectroscopy. So rest assured, this should be part of your cheat sheet. Let's list out our possible functional groups. And actually, you're going to notice that this is how our semester is lined up as well. All right, so let's start with our carbon and hydrogen. We have more functional groups. So far, we've seen our alkanes, and we saw them in two forms, right? We could have our cycloalkanes, and we had our alkanes, our straight chain alkanes. I love it. So we've seen these in our unit 1. Done. All right, but we can have multiple bonds between carbons. And with our alkanes, we now can see double bonds. Those are coming in our next unit. Those are alkenes. And we can have triple bonds. And those are alkynes. So those are coming. We will see those in our road maps in this unit and in our acid and base section. And then we're actually going to make them and use them starting in unit 3 for the rest of the semester. And these are all still carbon and hydrogen. And then you guessed it, as you're naming, you're going to end your name with "ene" or "ine" if that's your compound. So for example, this would be a butene or 2-butene. And then the same over here, this is be but2-ine or 2-butyne. Okay, so I love it. All right, we've got one more functional group that's just carbon and hydrogen, and that's our last unit this semester because it's got some pretty special energy with it, and those are our benzenes. Those are our aromatics. These are aromatic. So we will see benzene in our IR spectroscopy, and we will see benzene and substituted benzenes in our last unit. Okay, I love it. All right, so let's start to include 2 of our most common heteroatoms. 3 of our most common heteroatoms. And for us in organic chemistry, heteroatoms are anything other than carbon and hydrogen. So one of the first functional groups we're going to see reactivity-wise, we're going to make alkyl halides. And that can be a chlorine, bromine, fluorine, or iodine. However, in our class, we're going to focus on chlorine or bromine. And these are called alkyl halides. And we are going to make those in Unit 3. And then we're going to use them in Unit 3 and beyond. They are really good reactive species for us. So I love it. And then let's move into, so we've got our halogens. And then by far, our two most common heteroatoms are oxygen and nitrogen. So let's hit some of our common functional groups with oxygen. Let's start with our most basic oxygen. And that's going to be an alcohol. All right, so let's take something like this. All right, this is an alcohol. This functional group right there, these are alcohols. You can tell an alcohol by the ol in the name. So what would this name be? This is actually ethanol. Okay. So I love it. So we're going to have alcohols. They're going to be quite common. We will make those in Unit 3 and beyond. And then let's get a little sassier with our oxygen. It's possible to have multiple bonds to our oxygens. We can also have an ether. This is a nice ether. So in fact, this is diethyl ether, one of the original anesthesias. Okay, we can have double bonds to oxygen, so we can have aldehydes. Their name ends in al. Al. Okay, so this is an aldehyde. And we also have a ketone. And our ketones end in, you guessed it, own. So if you're really into your ketone or your keto diets, you've heard of ketone bodies. All right, so we've got ketones and aldehydes. And you notice the difference between the two. We've got a bond to hydrogen here. We've got bonds to carbon here. So they're very similar. They both have a double bond to oxygen, but an aldehyde has a hydrogen and a ketone has a carbon. Okay, now these are just samples. You can have all kinds of flare off of these as carbons. This is just to represent that functional group and what it looks like. And then we can get even sassier with our oxygens. We can go up what's called an oxidation level, and we can have a carboxylic acid. Like this is acetic acid. You guessed it, they end in acid or vinegar. And then we could also have an ester. A lot of esters have very fruity smells. They smell really good. So even though we're going to learn aromatics up here, yeah, they don't smell good. Our esters are the ones that are typically fruity smells. And we will not be making esters this semester, but we will see them in our roadmaps. They are one of those functional groups that will really be prevalent in Organic 2. We'll see them here and there in a roadmap, but we're not actually going to make an ester. We will make a carboxylic acid, however. We'll make those this semester. So that's actually all of our oxygen functional groups. And like I said, this is hitting 90% of OChem 1 and OChem 2. We're drawing the possible functional groups that you're going to see in your mechanisms, in your synthesis, and in your roadmaps. And then let's hit the last most common heteroatom, and that's going to be nitrogen. So one of our basic nitrogen functional groups will be an amine. We will make these and we will see these in our IR spectroscopy. So these are our amines. Our amines can be substituted in several ways. We can have a primary amine. we can have a secondary amine, and we can have a tertiary amine. All of these are amines. We're going to see an amide. We will make and use amides a lot in OChem 2. We really won't see them in OChem 1. We may have them in our IR spectroscopy, but we're going to hold off until OChem 2 for an amide. Again, we might have one in a roadmap, but we're going to use and see these a lot in OChem 2. And you notice your amide has both the C double bond to oxygen and your bond to nitrogen. This is kind of like the nitrogen version of a carboxylic acid. And then lastly, with our nitrogens, we're going to see nitriles. We've already started to see these in our acid-base section. These are called nitriles. We can have all kinds of substitution here. It doesn't just have to be HCN. We can have all kinds of functional groups connected to that nitrile. And we will see these. We will make these in Unit 3. We won't necessarily use them, but we'll make them in Unit 3. And we'll see them in our IR spectroscopy. So if I were you, what I would do on this video is try to take all of these functional groups and make them into a list on one sheet of paper. So this video is meant to help you with the rest of the semester. So I would literally make myself one giant list of functional groups. And you can add a little bit of flair, like maybe how would we name them, just a quick name. And then over here, I would leave myself some space because we're about to connect our functional groups to two different huge areas in this unit, pKa values and IR spectroscopy. So I would like you to start this list, and then we're going to fill in these two columns in our other videos. So we've got a nice acid-base video that we're going to add in some pKa data, and then we've got IR spectroscopy videos next. So this one is nice and short, just giving you some ideas on how to organize your notes and get started. So start that list of functional groups, and then check out our acid-base videos